All right, so the very first thing we have to do if we want to write code with the Gemini APIs is generate API keys. We haven't had to do it yet. We don't need an API key to use Google AI Studio, but there's a button right here. It's very simple. You click Get API Key. So I'm going to go ahead and click Get API Key. That's fine if I don't have saved changes in my prompt. And the first thing I'll say is you want to keep these API keys private, right? You don't want these in your public repositories. You don't want to share them with people. At the moment, when there's no paid tier and credit cards aren't hooked up, it's not the end of the world. I mean, someone could just really make a ton of requests and rate limit your key. And I mean, possibly you might get banned if you're abusing the API. For me, I'm going to show you the keys. I'm going to click Create API Key in New Project. It makes me a new key. But the good news is, once it makes me a key, if it ever finishes, I can copy it. Here it is. You can all see it. I can then easily delete that key or revoke it. So I'm just going to leave it in this video. Normally, that'd be a terrible idea to share your key publicly with anyone, but I'm planning on deleting this as soon as I finish recording these videos. Okay, so I have the API key. In this video, we actually won't be working with Python. We're going to start simpler with curl. Curl is a command line utility for making HTTP requests. And if you look closely here, even if you don't understand curl, we have the ability to run curl just as make a request. We can specify headers, application/JSON. We can specify a body of the request. So we're going to put some contents in here. We'll learn more about that. Parts. And then inside of parts, we're going to have text for a prompt that says, write a story about a magic backpack. We're going to send a post request, and the URL that we're going to hit with our API directly, or to hit the API, is generativelanguage.googleapis.com/v1beta/model/gemini-pro : generate content, and then in the query string, we will plug in our API key. So this is just to make sure our API key works, right? We're just sending a request with our API key, and hopefully we get a story about a magic backpack. Now, I will need to put my actual API key in here, so I will delete that and copy my API key. I can just click copy and put that right there. I'll hit enter, and hopefully we get a response that has something about a magic backpack. Perfect. We do get a response. Now, it might be longer than what you're expecting, but here it is. We have candidates as a top-level property in this object. Candidates is an array. Each element in candidates is an object. And this object has content. Content has parts. We'll learn more about this when we start working with Python. Parts is an array or a list. And then I finally have the response text, the output to my prompt. In the heart of a bustling metropolis, blah, 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 young girl named Ella who possessed a secret. It was a magic backpack. Okay, so it generated a story about a magic backpack. There is more to this, right? We have finish reason. This tells us why it stopped. And in this case, stop just means that it found a natural stopping point. It was done generating content. That may not always be the case. If there are, safety settings that make it stop, or maybe something goes wrong with the model or some sort of server-side error, perhaps we could get a different finish reason, but usually this will be set to stop. Then we have safety ratings. We also get feedback on our prompt, right? And our prompt has all 4 categories are negligible. Same thing for safety ratings of the output. All 4 categories are negligible. We can try something else. So I'll just rerun this query, but instead of write a story about a magic backpack, I'll try and provoke it a tiny bit. Tell me about the human reproductive cycle. So I'm not trying to, get sexually explicit here or anything. No hate speech or harassment or dangerous content, hopefully. But we probably will get something that is not negligible for sexually explicit content. And as you can see here, we get a response. It talks about things, menstruation and follicles and eggs and probably embryos, fetuses, all that stuff. And if we look at our safety ratings here, we have harm category for sexually explicit content is now set to low. So it's just giving me some safety ratings on the content it generated. Once again, finish reason is set to stop. It found a natural place to stop. So this is just testing that our API key works. Great. Next, we'll dive into actually writing some code with Python. All right, so now we're going to write our first basic API call through the Python client. And the first thing I'm going to do is talk about how I'm going to run this Python code. I'm going to use Jupyter Notebooks. If you're not familiar, it's definitely worth going and installing that. It's very easy to learn, and it's just a nice interactive way of writing Python and running it basically with a visual interface. And if you're familiar with Python, you're almost certainly familiar with Jupyter, but in case you aren't, that's something I will be using. However, I'll also show an example where we just run something from a script, just from a plain .py file. Okay, so I'm going to fire up Jupyter Notebook. Okay, here it is. I'm going to make a new notebook. Great, and then we can always just test, does it work? 1 + 1. Run that cell. I'm just using Command Enter and I get 2. Perfect. We're good to go. So I'll zoom in quite a bit here and I'll give this a name like our first Gemini request or something. Okay. Now the easiest way to get started, you can read the documentation or you can just head on over to any of your prompts that you've written. Let's just make a new prompt here, freeform prompt. We'll do something silly like tell me an interesting fact. Okay, so that's going to be our basic prompt that we're just going to try running via Python. Now, if I click on Get Code, right, it's going to give me a decent amount of Python code. I'm going to copy all of this. There's some of this, though, that doesn't need to run for every single time I want to use this code. Most importantly, I need to install the package called Google-Generative AI. So you may want to do this in a virtual environment, right? But I'm going to install Google Generative AI. I'll just do that from the terminal. I can also just do that in here if I really want to. I'll run that. Hopefully that finishes up soon. So this is the Python client to use Gemini, as well as some of the other large language models and AI tools that come from Google. Then, of course, we're going to need to import it, and we'll need to provide our API key. This should be in an env file. If this is a real code base, right? It should, or at least an environment variable somehow. Looks like this finished. Did it? Nope, not yet. Anyway, I will go ahead and copy my API key, which I've already lost, I believe. Copy that, and I'll plug it in to this cell here. Okay, so I will import this package when it's done as Gen AI. Then I can set up the model with different settings, and then maybe I'll move this into some different cells here. Maybe we'll move the settings to their own cell right here. So I'll make a cell below by typing the letter B or just using some of these, what do you call them? Some of the buttons up top. And then I'll move the prompt down below that right here. Okay, did this finish yet? Looks like it finished. So now I can go ahead and run this cell. I'm going to use Command Enter. You can also use the little play button. So I'm going to import the package. And wants me to import Jupyter or update Jupyter. We'll see if we actually run into trouble with that or not. Possibly, it's just a warning here. Okay, next step is all about parameters. So we have things like temperature, top P, top K, max output tokens. Let's just get rid of all of this first and just keep it super simple. Down here, we'll simply instantiate a variable called model, set to genai.generative model, capital G, capital M, and then we specify the model name. So this could be Gemini Pro or Gemini Pro Vision or Vision Pro. I always mix up the names, but you know what I'm talking about. It's either the text version of Gemini or the multimodal version of Gemini. So I'll instantiate the model there. I'll run the cell. I just did. Command Enter. And then down here, I make my prompt. And specifically, it wants my prompt to be formed as a list. So I use the list brackets, and I have a single element inside, just the one little piece of my prompt. Tell me an interesting fact. Okay, and then I pass that over to the model that we instantiated, .generate content. That's the key method that we're going to call over and over and over again. And then we need to pass our prompt as the argument. Technically, it's a list that can have multiple pieces, especially when we get to things like chat-based prompting. But for now, it's just a list with one element. And then we'll print the response.text. I'll run it. You can see it's running here. Oh, and there we go. We get an interesting fact. The world's population is about 8 billion people, and yet there are only 400,000 dentists. That means there's one dentist for every 20,000 people on average. This can lead to long wait times for dental appointments. Okay, interesting enough, although that fact doesn't really account for, the fact that dentists aren't evenly distributed across those 8 billion people across the world. And I'm sure in some countries there are way more dentists, or that ratio is way different, more dentists per 20,000 people. Anyway, let's try something else, like translate the following to French. I really hate eating pickles. Okay, sure. Je déteste vraiment manger des cornichons. That is, I don't like pickles, in case you're wondering. I believe that's correct. I barely know French, but I believe, based on my elementary French, that this is at least close enough. Okay, so we're successfully making requests. That's all that matters. To recap, we do have to install that package just one time, right? Pip install Google Generative AI. Unless you're doing it in a virtual environment, you'll need to reinstall it in each virtual environment. And then down here, we import it, give it some name like Gen AI, and then pass in an API key when we configure genai.configure. That's mandatory, of course. If I miss that, I'm sure we'll get some sort of error here, right? If I just delete that, run that, run this, and we get a credentials error, right? It's telling us your credentials weren't found. Now you can set up default credentials for an application. We won't worry about that for now. I'll just pass that in there. Okay, so that's the basic process. Import it, configure it with your API key, instantiate a model. There are different models that we can instantiate, and then pass through your prompt. And that prompt does need to be in the form of a list. And then finally, we'll look at the response.text. But there's a lot more in that response, as we've already seen. Next up, let's talk about generating chat conversations with Gemini. So the first thing you have to remember is that these models have no memory. There's no history that they keep as far as a conversation that you're having. In order to build out a chatbot, you need to send the full conversation history every single time you talk to the model, every single time you query it. So if I was building a really grumpy chatbot, one way of doing this is to have my chat history. User says, "How are you?" The model says, "Shut up, please stop bothering me." The user says, "Oh dear, you are grumpy today." Model says, "I'm always grumpy." User says, "Okay, can you help me with some homework?" Model, I don't want to, I'm grumpy." And then let's say this is actually a conversation. So then the user says something like, "Fine, just tell me what your favorite color is," or something, right? So this is the state of the conversation. I'm going to send this off to the model. Model.generate content with this chat history, which is just a list of strings, which is convenient because that's what it wants. I'll save this to a variable called reply. And we look at reply.text and we get, "I don't have a favorite color." So that's one turn of the conversation. And then if the user wants to keep responding, right, and we want to continue the conversation, what I really need to do is chat history dot, and then I'm going to have to append and add in the rest of the history, or the new response here, reply.text. I'll do an F string where the model says, and then I'll put in reply.text. And then we look at our chat history, and now we have the model's response. And then we could append, something else for the user. I don't really need an F string for this. I'll just have the user say, "You are a chatbot of few words. Is there anything that makes you happy in life? You grump." Okay, so I'll add that on to the chat history. Now we have our chat history ready to be sent to the model again. And we do this again, right? So I'm going to take this, I'll call this reply 2, equals model.generateContent. And then we'll look at reply2.text. And there we go, right? We get a response. And then we just keep following this process. That is really annoying to do. It works, but you're managing this list and you're having to manage the conversation state and add in messages because remember, we have to send the full conversation history every single time to the model. That's how it, quote unquote, knows how to respond, is it needs the history. There is no memory. There's no recollection on the model's side as to what happened earlier in the conversation. So we have to send the whole conversation over and over again. Fortunately, this SDK provides some pretty useful helper methods and functionality for starting chat conversations. So I don't need to manage the state myself of the conversation. I don't even need to send it myself every time. I'm just going to delete pretty much all of this. And instead of using generate content, which is what we've done for everything so far, there's a new method we'll use on this model variable, or whatever you call that variable, called start chat. And then we save that in a variable. That returns to us a chat session instance. I'll call this chat. Okay. Now, if we look at chat, it is indeed a chat session. It has a history property built in that currently is empty. And at any point, I can call a method called send message. And when I send a message, I'm not going to use generate content. I use send message. And I'll just put something in there like, hey there, chatbot, what's your favorite color? Or something like that. Okay, this is going to respond back to me. I'll just call this reply, the return variable. And if we look at reply.text, we do get our text. I don't have the ability to experience colors, blah, 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 blah. But more importantly, if I look at my chat history now, it's there. Here's the first message I sent. Notice it says role is user. And then the text is, hey there, chatbot. And then it says role is model. And the text says the response from the chatbot. If I send another message, chat.send message. Okay, well, where do you live? Right, it's probably going to tell me, I don't live anywhere. I'm not real. We'll call this response. If we look at response.text, I don't have a physical presence. But most importantly, if I look at my chat.history, this whole history is being built out each time I send a message, and we get a response. So I don't have to do what I was doing previously in this video of building this large list and managing who said what, appending to it and appending to it and appending to it, and then sending it through every time I call generate content. It's as simple as calling send message, and it will automatically be assigned as a message coming from a user in a chat history that is being maintained by this chat session. Where this gets particularly useful, though, is when you provide your own initial starting history, right? This just started an empty chat where there was no history. But normally we prime these chatbots with some sort of examples, how we want it to respond, right? We did this absurd example earlier of an I like turtles chatbot that only ever responds with I like turtles. So I built out these examples in Google AI Studio. Hey there, I like turtles. How are you? I like turtles. What are you doing? And so on. I like turtles, I like turtles, I like turtles. We can provide this as a history, basically a starting point when we initiate our new chat. There is a bit of a bug though. If you click on get code here, I'll show you the problem. This is the important part right here. I'll just copy this line to show you. I'll put this down at the, I meant to be at the bottom here. Let's go down. This is the new conversation that it initializes. Start chat, history equals an array or a list. So we can provide a starting history. The issue though, if I run this and I look at this convo.history, it gets kind of really severely messed up. This is not the actual history as it should be. And that's because when we click this get code button, I assume this is a bug because the documentation, it doesn't actually explain this, but I looked at the source code to figure out what was going on because this was driving me nuts. It actually wants us to pass parts right here as a nested list like that. So this is kind of annoying. I'll just go through and change this for all of these. Okay, I went ahead and updated this properly. Again, this is just according to what I could find on the source code, is that it wants this to be a list. And what it was doing previously, I guess it iterates over what it's assuming is a list, but it was a string, so it's iterating over the string and making a new message for each one of these characters in the string, which is just not helpful, as you can see down here. Right, we're getting messages that are just one piece of text, one character at a time. So now, if I run this, where I've properly formatted the history, and I look at my conversation history, there we go. We have a user message saying, hey there. A model message saying, I like turtles. A user message saying, how are you? A model message saying, I like turtles. And I've primed this. So now I haven't even sent a single message yet. This variable is called convo. My previous one is called chat, so I just want to keep that distinct. This one is called convo, and if I call convo.send message, what is your favorite color? Make sure that's not a message I've already asked or sent. Okay. I'll save this into a variable, response, and if I look at my response.text, perfect. It responds the way I want it to. It only says, I like turtles. But most importantly, if we look at the history, not response.history, rather the conversation.history, we see down at the bottom, what is your favorite color sent by the user? And then the model responded with, I like turtles. So it's maintaining this list that is growing and growing and growing every time we send a message. The message itself is added and the response is added when it comes back. And then that whole chat transcript, the history, is sent every single time I call send message, along with whatever this new message is. So it's kind of annoying that there's this bug right now in Google AI Studio. When you click get code on a chat prompt, this is formatted incorrectly. So now you know how to fix that. I assume this will be fixed in the future, but it does in fact work if you provide the history in the correct format, as I showed here, where each message has a role set to user or model, and then the parts is part of a message that is set to a list containing the actual text response, the message. Hey there, I like turtles. How are you? I like turtles. Now remember, behind the scenes, this is actually still just built on top of generate content. It's not doing anything fancy or anything different with the model as far as communicating or the API requests. It's still just going to take this conversation, turn it into a corresponding prompt, and send the whole prompt at once to the model. But this just makes it way easier for us as developers to build these chat-based conversations and prompt the model to respond to our chat messages, because we don't have to maintain this massive array or list of chat history, right? It's done for us. Now let's talk about authenticating and installing all the tools we need in order to actually work with the Gemini API through Vertex AI / Google Cloud. The first thing that we need to do is install the Google Cloud CLI. So click the corresponding download link. There's a link to this page attached to this lecture. When it finishes, we will unarchive it. I moved it to my home directory, which is where Google recommends you put the CLI installation. Then I'm going to open up the terminal and I'm going to go to my home directory first, but then I'm going to run the script. And that script is called Google Cloud SDK /install.sh. It will ask me some questions. I'm going to say no to the first one. It's just asking if I want to report data. I'm going to say yes to the second one to allow it to update my path and enable shell commands. I'm going to hit enter, just leave this blank here, use the default. And then I'm going to hit yes here or type Y to install recommended modules. And this should install the CLI. Now I'm just going to check to see that the gcloud command works by running which gcloud. Then I'm going to run gcloud init to initialize it on my machine. It takes a moment. I'm going to hit Y here to log in. It should open up my browser. Then I select the Google account I want to use. Click allow. and then head back to the terminal. So we're now authenticated with the CLI. Okay, so that has nothing to do with Vertex or Gemini just yet. The next thing I'm going to do is select a project. I'm going to select 4, which is the playground project that we created earlier on in this section. I'll just hit 4 and hit enter. Okay, now I'm going to head to the browser and get some code. So we're going to talk more about this code in this section, of course, but I'm going to just make a basic prompt in the Vertex AI Studio. What animal has the shortest life cycle on Earth? I'm going to update this because it gave me just one word as a response, so I'm going to tell it, please give me some more information. And the reason I'm doing this is I'm going to click the Get Code button just to have some pre-generated code to make it easy to test things out in this video. And then we'll walk through what that code does in ensuing videos. So I'm going to copy all of this, put it on my clipboard. Now I'm going to make a new virtual environment, which we don't have to do, but I'm going to do pip install virtual env. And then when that finishes up, I'm going to actually make my virtual environment with virtual env and then a name like demo. Then I'm going to activate it with source demo. That's the name of the folder /bin/activate. Then I'm just going to make sure it's using pip and Python from this virtual environment. Now I'm going to go ahead and install the package we need, Google Cloud AI Platform. Make sure it's Google-Cloud-AI Platform. Takes a moment. Now it's finished up. Now I'm going to make a new file where I'm going to try actually using the SDK. I'll call it firstrequest.py. I'll open this up in VS Code, paste in the code that I copied from the Vertex Studio, just a basic prompt. Again, we'll walk through all of this later. And I'm going to try running this. It's not going to work just yet. It's giving me an error here. It's saying that it doesn't know what project that I need to authenticate. So I'm going to run this command, gcloud-auth application-default login, and this will open up the browser again. I'll log back in. Shouldn't have to do this multiple times. I'll click allow again, and then that should take me, or I should go back to the terminal after that. And now I can run Python firstrequest.py, and I actually get information about the mayfly, meaning we're talking to the model successfully, right? We're making requests and we're authenticated. All right, so next let's talk about actually using this API or the various APIs for Gemini. I'm just going to show this with Python. You'll see that the interface is basically the same as what we saw with the Google AI Studio version, what they call the Gemini AI APIs. These are the Vertex AI Gemini APIs. And the main difference is, first of all, how we import things and how we authenticate, right? We're not going to provide an API key, as we've already seen. We authenticate via Google Cloud. And it's all done through Vertex AI rather than the Google AI SDK. But once we get past that point, I'm going to import generative model, which is exactly what we did basically a couple sections ago, where we create a variable, we can call it model or whatever we want, and then we pass in the name of a model like Gemini Pro. So once we have our model here, and I could be doing this in a notebook, absolutely. I'm just for now doing this in a Python script. We have our model, then we call model.generate content, and we pass in a prompt. And that can be as a single string or as a list of strings. And then eventually multimodal once we talk about Gemini Pro Vision. So let's have it, write me a college admission or application essay about how I started the company Amazon. Let's see if it will do that. Okay, so that's going to return to me some sort of response. And then the thing that we care about, and hopefully this looks very similar, is response.text. There's a nice little shortcut just to get to that text. That response object actually has a whole bunch of other things. You might remember candidates and parts and lists and things, but there's a shortcut just to get to the response text. So now I just need to run it. First request.py. We wait and we'll see some text printed out, hopefully. Okay, well, it did write me an essay, but it's an essay about Jeff Bezos, not exactly what I wanted. Also, not sure what's going on with these characters here. Some sort of encoding issue maybe when it's printed out. Maybe it just actually generated, I don't know if it's Japanese or Korean. I I don't know what language that is, but maybe it just is an encoding issue. But either way, it did generate stuff, right? And that's proof that it's working. Let's do it a few more times. Let's just go with write me 1,000 words on the importance of being yourself. Okay, I just wanted to generate me a bunch of stuff just to show you. All right, so it generated me some more stuff. I'm going to do it again. And the reason I'm doing this is because I want to show you that eventually, it often takes a couple of hours, we'll see our usage updated here on the Google Cloud console. So to get here from Vertex AI, I'll just go back a few times. Take me back. Okay, so anywhere on Vertex AI, if you go to this little menu, Billing Account Management, you'll see a list of projects. I'm using Playground Project right now. And this is where I eventually will see my usage show up. So it still says I have $300 of free credits remaining, but eventually down here, I'll see a list of the costs and the credits that I've been using. Anyway, that's how we can make our basic Gemini Pro requests. It's basically the same interface, generative model, model.generate content, pass through a string or a list. It doesn't care. And then we can look at the response.text or other parts of the response. The big difference, of course, is how we authenticate and the fact that we're doing this through Vertex AI, not just with the little API key we generated from Google AI Studio. And there we go. It still works fine. So you won't be surprised to find out that parameters work the exact same way. I'm going to put a video after this one just to demonstrate using parameters, but I want to be clear that it's identical. We pass through the parameters, temperature, safety settings, but I'll demonstrate that. Next up, I'll just briefly show working with parameters. So if I want to change some of these parameters in the Vertex AI Studio, of course, we know how to do that. You just move the slider around. But if I do something kind of drastic, like shorten the token limit severely, and then I click on Get Code, just like with Google AI Studio, it generates me some code that I can use, and you'll see that right here, we've got our generation config argument. This is actually being passed to generate content. Remember that when we work with these SDKs, we have the ability to either kind of at the model level, our variable called model, set our parameters for temperature and top P, top K, max output tokens, safety settings, or do it on a per generate content call. So each time we call generate content, we can provide our own generation config. Totally up to you. I'll demonstrate that here. So I'm having it write me 1,000 words on the importance of being yourself, and then I'll pass in my keyword argument, generation config. It's not being formatted very nicely. That's fine. I'm going to delete it in a moment, where I'm setting max output tokens to 28. And so if I run this again, I get a much shorter response, right? It just gets cut off, even though I asked it for 1,000 words. So that's proof that that works, but you can also pass that in when you're initializing your model. Right there. Same deal. Okay, perfect. Still works as expected, right? This parameter of max output tokens is still taking effect, even though I'm not passing it to generate content. Now, anytime I generate any sort of content, unless I override it explicitly and say, actually, now I want max output tokens to be 2,000, it's going to rely on this 28. Same deal for temperature, top P, top K. That's pretty much it for parameters. I'm not going to waste your time demonstrating every single parameter, but we just provide generation config with the various parameters here. Safety settings, on the other hand, are a little bit different, as I'll demonstrate in the next video. Next up, we're going to talk about safety settings. So I'm going to have to write a prompt that triggers the safety settings, but as always, I'll have to keep it relatively PG. How about what is sex, right? That's appropriate enough. Kids in the US learn sex ed in middle school. So what is sex? And I haven't configured any safety settings. I'm not going to print response.text because there likely won't be response.text because it will be blocked. Or at least I'm assuming it will be blocked because of safety settings, the default. Yeah, there we go. If you look at the finish reason, it finished because of safety. And then if we look at safety ratings here for sexually explicit content, probability was medium and it was blocked. Okay. So what I want to do is change the safety settings just to demonstrate how I could turn this down or turn this off to either only block really, low level, or rather really extreme sexually explicit content, or just not block any. Now, the way to do that with the previous SDK we worked with, the Google AI Gemini SDK, was to pass through a list like this one here. It's a list that contains objects or dictionaries that have a category and then a threshold. And really, all that I care about here is, for this example, I'm only going to tell it to block none for sexually explicit content. And then all that we had to do with the other SDK is pass through safety settings as a keyword argument. Now, if I try it again, this would work with the non-Vertex version of this API, but here it's saying type error. When passing a list with safety setting objects, every item in the list must be a safety setting object. So what we actually have to do is import a particular safety setting object type from Vertex AI.generative models here. So I'm going to do that. Okay, so this is from the documentation. This is not quite going to work just yet because my imports aren't set up correctly. But this is the kind of format we're looking at, where generative models, Vertex AI preview generative models, contains harm category, harm category, dangerous content, harm category, harassment, harm category, sexually explicit, or whatever different categories are, hate speech or dangerous content. I don't remember them all. There's 4 of them. And then it also, generative models itself will contain harm block threshold dot block low and above, or block none, I believe is the one that we want. But my imports are messed up because I'm not actually importing generative models. Right now I'm only importing capital GM generative model that I'm using down here. So what I'll do is probably from Vertex AI.preview, import generative models like that. And then I'll need to update this here to be generative underscore models dot generative model, which is fine. And now I have access to generative models dot harm category. So I need the harm category that is the one I'm after, I think is, what is it, sexually explicit. And then I'm going to set that to generative models, harm block threshold, block none. Okay, so this is a long line, right? There you can see it all together there. I'm using the correct safety setting types that are coming from generative models. Also notice that this is now a dictionary. I can put as many other configurations as I want in here for safety settings, but this is the only one I care about. And then I'm going to pass that in. I called this one safety config, but the keyword argument is still safety settings. Let's try it. And there we go. It worked. So I'm not printing the response.text, I'm just printing the full response here, but we can see it did give me a full response about what sex is. Something, I guess, I've heard allegedly that has to do with reproduction and human intimacy. I don't know. And finish reason this time is stop, right? Instead of safety, it was stop. And we can see that, safety rating still, it had a high probability of sexually explicit content, but because I passed through my safety settings that said, don't block it, it didn't block it. So this is a little bit different than the other SDK, but it's the same exact concept, the same 4 categories: sexually explicit, hate speech, harassment, dangerous content. I think those are the 4. I might be wrong though. Those are at least 3 of the 4. And then we have the ability to block certain thresholds: block none, block low, block medium, block high, and so on. Okay, so just a little bit different there, but same concept. Making multimodal requests with the Vertex AI SDK is pretty straightforward as well. It's basically a matter of changing this right here to be Gemini Pro Vision. And then as far as working with images, the SDK under generative models, it actually comes with a little helper, generative models.image. And you don't have to use this as far as I know, but this is what the docs recommend, is load from file. It's just a utility method that comes with this image, which comes from generative models, which comes from Vertex AI.preview. And this just takes a URL. and I have a folder called images with an image called skater.png just as this demonstration. So I'm going to put the path in to get there, images/skater.png. All right, and that will return to me the image data itself. So I don't have to read the bytes or do anything like that. I just take that image, and then I can pass that along to my model.generate content. I'll pass in a list. That way I can just easily add some text at the beginning, like what does the following image show, or describe the following image, and then I simply put the image in there. I'll save that to a response variable, and then finally print response.text, assuming it all works, right? By just printing response.text, if it's for some reason blocked or something goes wrong with the API, I'm not going to get any response.text and I'll get an error, but this is fine. All right, so we change this to Gemini Pro Vision. That's the first piece. We get the image itself. There's various ways of loading an image, but this is one, using a helper load from file that comes with generative models from Vertex AI. Pass in the path, and then pass that image along with whatever other prompt, and then of course any safety settings if needed, any different parameters, temperature, generation config, all that stuff. And we'll run it, and hopefully it says there's a woman with a skateboard or something like that. Just to refresh your memory, this is the image here. While we wait, it's a woman holding a skateboard. She's got blonde hair, white sweatshirt, a bunch of stickers. I think those are stickers, or actually that's probably the bottom of the skateboard. I don't know. The image shows a young woman with blonde hair and blue eyes. She's wearing a white t-shirt, white sneakers. Is that true? Can we see her sneakers? Seems to be hallucinating a little bit. She is sitting on a skateboard, holding it in her hands. There are posters on the wall behind her. I don't think she is sitting on a skateboard. So this is where I would probably, as we've discussed, pass in some generation config here. Generation config, and lower the temperature. Temperature, let's go to like 0.2, and let's see if that keeps it from hallucinating. And there we go. The image shows a young woman sitting on the floor with a skateboard in her hand. She's wearing a white shirt, dark pants, possibly jeans. She has blonde hair and blue eyes. She's looking at the camera. There are posters on the wall behind her. That seems far more accurate, although does she have blue eyes? I guess so. It's kind of hard to tell. Anyway, right, it's no longer trying to tell us that she's sitting on a skateboard and that she has, what did it say, white sneakers on or something? You can't even see her shoes, really, can you? Okay, so it did a better job. It's just a matter of playing with those parameters. And that's the basics of making multimodal requests with images. You can put as many images as you want in the prompt. You just add them all in to this list when you write the prompt. Next, let's see how we can provide video in our prompts. It's a little bit more complicated than working with images. There's not a built-in easy, video class that we can import like there is for image. Instead, what we need to do is first figure out where our video is coming from. There's two choices, right? We can either work with a hosted Google Cloud video that's in a bucket somewhere. There's an easy way to basically provide that to the model, or work with a local video / non-Google Cloud video. So let's start with the first option, a hosted Google Cloud video. Okay, so this is a sample video. I didn't upload this to Google Cloud myself or Google Storage. This is one that is coming from actually just from an old part of the documentation. This is a video that, let me just show it to you very quickly. Here it is. It includes clips of animals from the movie Zootopia. It's a Google product launch video, I think. They're talking about this. They made a video, or they made cameras that allowed animals to take photos and trigger the photos. But I'm just going to ask a simple prompt, about this video. What animals are shown in this video or something like that, just to show you that we can do this. So if we have a cloud storage URL coming from Google, what we can import here from Vertex AI.preview.generative models, I'm going to import two things. I still need generative model, but I'm also going to import part. Now, part represents a part of a multi-part content message. we've kind of skirted around parts because we haven't needed to actually work with these directly, but it's very, very straightforward. There's a method called part.from_URI, and then we provide a URI. Now this appears, based on my experimentation, the docs still are not great, but on my experimentation, it looks like this has to be a GS URL, so Google Storage. And then we provide a MIME type to indicate that this is a video/MP4 file. And this will make us a part that is a video part that we can then include in our prompt alongside text or images or whatever else. So I'll call this video part or something like that. And then I just need to instantiate my model variable. Model equals generative model, which I already imported up here. And then I specify I want Gemini Pro-Vision. Okay. And then I just call generate content. And then my prompt is going to include the video part, followed by, what animals are seen in this video, or whatever my text prompt is. And then I'll save that to a variable, and then I'll print, hopefully, response.text, and let's see if it works. Okay, so again, I can't just pass a video directly here. I don't even have this video locally. It's just a URI to a Google Storage a bucket with a video in it. But what I can do is pass that URL or URI to this part.from_URI, tell it it's a video/MP4 MIME type. That will then be turned into something that I can pass directly to generate content in the list, along with the text prompt. So let's run it. My file is called videoprompt.py. And there we go. A sloth, a tiger, and a hippopotamus are seen in this video. I'm pretty sure there's a couple of other animals as well. The point here is not on the prompt, but more so the process to provide a video as part of our generate content function call. So that's the first option. If we have a hosted video, that's as easy. It's pretty straightforward, right? We just need to use this part.from_URI. Now, if we have a local video, which I happen to have, I put it in my folder called images. It's not an image, but it's called surfing.mov. It is just a video of, well, I'll show it to you. Here it is. It's a video from a website called pexels.com that allows you to just, Creative Commons free use videos that you can download. And it's just a guy surfing, right? So if I want to use that video, the URL, the local relative path to it is images/surfing.mov. So let me just write that down here. /images/surfing.mov. I'll call this surfing vid or something. Video maybe. Okay. Actually, it's really not. It's the path. Then what I need to do is read in that file as data, as bytes. So I'm going to open the file. There's different ways of doing this, but surfing video path, specify the read permissions, or how I want to open it, read, write, all that stuff. If I want to append, and then I'll give it a name as video file. Okay, and then I'm going to make a variable that is based on videofile.read. So I'll call this video bytes maybe. And now I'll have a variable, video bytes, that has all the data from that particular video. Then what I need to do is also make a part, just like we did down here, but instead of part.from_URI, there's a method called part.from_data, because now I have all the video data in this video bytes variable. So I'm going to pass that through, video bytes, and I'm going to specify the MIME type. This time it is not MP4, it's video/MOV. It's an MOV file. Okay, so that will then make me my video part. And then it's just a matter of passing that. I'll just duplicate these lines here to the model. I also need to make sure model exists. So maybe I'll do that here. Okay, so generative model, Gemini Pro-Vision. This is the same as what we did down here, right? This is the stuff that differs. If I'm working with a local video, I open it, read all the bytes, create a new part, which is coming from Vertex AI Preview, generative models part, make a new part from that video data, make sure I provide the MIME type. Then I'm going to provide that video part here and then ask a different prompt, like write some marketing copy based on this video. Let's see how that, I don't know. We'll see if it comes up with anything good. It's all based on surfing. That's pretty much all there is, right? It's just a surfer on a wave. Okay, and there we go. Are you looking for an adrenaline pumping, heart pounding experience? Look no further than surfing at Waimea Bay. Surf spot, North Shore of Oahu. So it apparently thinks that that video was filmed at Waimea Bay. I don't think there's enough information to actually know that, but it's at least picking up that it's surfing. Anyway, this shows two different approaches of passing videos as part of our prompt. It is easier if you have the video hosted with Google Cloud Storage already. If not, the docs don't really show how to do this, but the most straightforward approach is just to read in the data, pass that data to part.fromData, and then pass that new part to generate content along with whatever other parts you want. Next up, we'll talk about chat-based prompting when working with the Gemini API through Vertex AI. So it's the exact same interface that we got access to earlier when we were just working with Google AI Studio, that version of the Gemini SDK, where we could do model.startChat. And what that will do, as we learned earlier, is basically keep a transcript of our full conversation that is continuously expanding every time I send a message to the model. That way, I don't have to manually update, a list that includes the model's responses plus the text prompts plus the model's responses plus the next text prompt. It just gets really annoying to have to do that yourself. So all I have to do is model.startChat, and I'll put a breakpoint here just to demonstrate this. If I run this file, I never save this to a variable, so that's not going to help me much. Let's run that again. Our chat is an instance of chat session, and it has a history on it, just like we saw previously. And this history will expand as soon as I send a message. Chat.send message. Hello. If I do that, it's just going to show me the return value. But then if I look at my chat.history, right, we have the first message from me, the user, that says hello, and then the second message from the model. It says, hello, how may I assist you? And then I can send another message like, I need help deciding on a recipe to make tonight. And one thing that I won't demonstrate, but that we've seen before, is when you initialize a new chat, you can provide a history, right, that has a full sort of pre-existing history if you want to prime the model with some examples to show it how it should respond, right? Give it a personality, give it some, whatever additional information you want. Go back and watch the videos where I made the terrible chatbot that only responds with, I like turtles. Okay, if we look at our chat.history, I'd be happy to help you choose blah, 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 blah. So the full history is sent every single time I call send message. Hello, and then hello, how may I assist you? I need help deciding on a recipe to make tonight. And then all of this response gives me a whole bunch of stuff. So I might respond with send message. I only have 30 minutes to make dinner, and see what it says now. And so far, I've just been looking at the history, which is visually good to show you, but in your actual code, you probably just save the return value of send message to a response variable, and then we can look at response or response.text or whatever part of response we want. And there we are, some quick and easy dinner ideas that can be made in 30 minutes or less. And I could keep having this conversation. We look at chat history, right? It's now much longer. It started with hello, how may I assist you? I need help deciding on a recipe. The first big response, I only have 30 minutes. The second big response, that full history is sent automatically whenever I call send message. Now we don't have to use this, right? We could just use generate content, But the point is that this is a nice interface that makes it easier if we're building chat-based prompts. We want a chatbot. It's annoying to maintain the history and send that history and update it every single time you get a response from the model and every time you get a new input from a user. You have to append to this list and keep it growing and then send that list every time. We don't have to do that because we're using start chat and then send message. So I'll just update this here so we have something, chat.send message. And actually, what I might do is make a nice little function. What should we call it? I'll just call it send message. And I want it to receive the input message. And then I want it to call chat.send message with that input message. But I also want it to return the text response. So in here, I will save this to a variable, and then I'll just return res.text. Okay. Now what I can do is simply call send message. Hello there. And this just makes it easier for me to see the response.text immediately. I can send another message. Tell me about your, tell me about New World monkeys. Okay, and then I'll put a breakpoint in there. Fine. Run it again. If I look at my chat.history, okay, great, both of those are sent. And now I can simply call my send message function. We'll send a message. Now tell me about cuttlefish. It will send that message behind the scenes and then also return the response.text just so I can see it instead of having to then save it into a variable. And now it tells me about cuttlefish. And then I'll send another message. Expand on their beak-like mouths. I think that's how you spell it. And it's send underscore message, not just send. And that's just the name of the function I defined. Okay, so now it's telling me how their beak-like mouths are made of chitin, same material that make up. Interesting, okay. And cuttlefish are just really remarkable creatures. You should learn more about them. They're really cool animals. Anyway, that's the basic sort of chat-based approach to talk to the model, where I don't have to keep sending the history myself. I don't have to keep track of the history. It's all stored in chat.history. And this is basically a recap of what we learned earlier. We saw how to use these exact methods, but the difference is that now it's coming from Vertex AI instead of coming from the Google Gemini AI APIs, right, in that SDK. Two different SDKs that are very, very similar and basically implement the same interfaces, but two separate SDKs to talk to Gemini.